Super excited. Good to see you.
Happy Friday. Happy Friday, everyone.
Happy Friday. All right, so Carmen, you've been coming here for a few years, actually.
I have. You aged me. But
Yeah,
yes.
yeah, a few years, yeah. So
By 4 years.
Talk a little bit about what you're going to be sharing with your panel today. You're mic'd up.
I'm mic'd up.
You don't get
Forgot
this.
about that. So I feel my topic has been changing throughout the years. Initially, we talked about GPUs, servers, all hardware-centric conversation. Today, we talk tokens. It's fantastic. I think people moving from, hey, we care about GPUs for real, but at the same time, we care about tokens, right? That's how you and me consume intelligence through tokens.
Right. So why is this important, and why have you dedicated so much time in your life to distributing this to the world and falling in love with this space?
I think at the end, everything we do here, from GPU to server, co-location energy, at the end, the output is token intelligence. We all working for the end goal is how do we improve productivity, efficiency for humanity as a whole? How do we consume that through tokens, right? So at the end, we all working for the ultimate goal. How do we make things efficient, make things smarter, and then more transparent? And token is the best way to measure anyone's sort of output, right, in terms of efficiency and improvements.
Okay, all right. Well, there's much more to learn. We'll let you and the panel take it away. Please put your hands together for Carmen.
Thank you, Carmen.
Happy Friday. I'm jealous that I couldn't participate in giveaways. I love the backpack. Whoever got a backpack. So my name is Carmen Li. I'm the CEO for Silicon Data and the Compute Exchange. So the two companies. Silicon Data is a data intelligence layer. So we publish indices on Bloomberg, Refinitiv. We also publish benchmarking services for GPU performances, etc. Compute Exchange is a GPU marketplaces for reserved GPUs, forward contracts, reframe GPU transactions, and you get actual GPU resources from us, which is fantastic. So I'm going to talk about tokenomics with my amazing panelists here. So before I start, I want to quote Bloomberg data. So the token prices, the token expenditure indices, you go to Bloomberg, you can search for SD, LIM, TK indices. So it went up from $1.20 per $1 million token prices to $1.55 today per million token indices. So there's a mixture of all input token, output token based on the transactions. So that's about like 40% price increase since January this year to end of April. So 40% price increase for tokens price. If you look at GPU, B200 on-demand NeoCloud per GPU per hour rate increased from $4.40 to $5.30 today, right? It's about 20% price increases. You think a NeoCloud's margin or anyone's margin is the revenue you get from tokens minus the cost per GPU per hour, right? So how would that work for the commercial models, application layer to LLM models? How would that commercial model going forward, how would that change to people's ROI? That'll be all interesting discussion we're gonna have. So welcome to the panelists. We have Vaughn from Vast Data. And then we have Wilson from Tencent Cloud. And then we will fill in the gap for John. Unfortunately, he couldn't make it, but we're gonna have ample time for discussion. All right, please sit. So I will let you introduce yourself really quickly, but before I start, love to understand where you're coming from. What part of tokenomics excite you?
I guess I'll go first. Vaughn Stewart with Vast Data. I lead our systems engineering team. We're basically the part of the organization that engages with customers directly and represent the efforts that our R&D team have brought to bear in the market. My interest in tokenomics is really a representation of my customers' challenge within the tokenomics. We are considered the de facto data platform within the neoclouds. And so as our neoclouds are continuing to expand their business at an ever increasing rate on the inference side, tokenomics are becoming a significant consideration for them. And so we are helping them to address that challenge. And ideally, we'll talk about some of those concepts here.
Hi, everyone. This is Wilson Liu. I come from Tencent Cloud. I'm the Solution Architect Director for the B2B business. And in terms of the token economy, I think Tencent Cloud sits in both the consumer side because we use a lot of tokens in our game studios and social network, and also we are providing some of the AI inference, even large language model ourselves. So we are on both sides. And the good thing is when we provide the service to our enterprise customers, we have our internal use cases. We do know how to leverage tokens on game development, and we do know how to leverage into, for instance, media generation, enhancement of the media quality, so on and so forth.
That's great. Since you have the mic on, I have a follow-up question on that. So what does Tencent think about token economic internally? Because you talk about internal use cases. How does that translate to what you're offering to customers of Tencent Cloud?
Yeah, one of the interesting use case, talk about Tencent is really a decent large organization. We have more than 100,000 employees globally. So internally, we used to have this debate whether what's the best way to use tokens very effectively. But in the end, we decided, the senior management decided to give each and every employees several hundreds of millions or even billions of tokens for their innovation. You think about 100,000 employees, each of them have a mass amount of token to experiment. That's really encouraging people to leverage the AI capability to drive efficiency and innovation. Yeah, so of course, during the practice, we also observed some areas where some sort of tokens or some sort of wasted. So we also come up with the idea how to drive effective use. For instance, we came up with the idea when take an example, we were using the configuration migration as an example. Overnight, I think we were using a lot of tokens to explore how to make the best use cases. But in the end, we have another interesting other agent to summarize what the mistakes the AI has been making. Then later on, do optimization and formalize, maybe generating a script, Python script. So the next day, it won't consume that many of tokens. So with that kind of summarization, or we are putting together some AI inference gateways to help our customers to make best use of the tokens provided and just drive the efficiency. End of the day, it's not really the cost of tokens, but it's cost of the per jobs we really want to achieve.
The ROIs for the customers, right? Vaughn, it's a great segue to you, actually. So we talk about cost per token, right? So you work with a lot of enterprises. What's the bottleneck, performance bottleneck you have seen with them in terms of like storage layer or data layer? You see that make that cost per token high.
Yeah, it's a good question and one that I could provide a simple answer, but we've got a little bit of time here, so I'll give a little bit more of an elaborate answer. I won't go very deep, but at the end of the day, to obtain the capabilities that are provided to us through GPUs, regardless of the use case, there's a tremendous demand on the infrastructure to be able to access your data. And we think about that in terms of like devices. Usually someone goes, oh yeah, okay, I got a storage device and a networking and a cable and blah, 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 GPU. But when it gets to data, the data in your data center, it's varied greatly in its format and its text in its context. It varies greatly based on the protocols that access it. Enterprises are filled with just silos of data, and they've got different authentication mechanisms, and so you have challenges, or the enterprise has challenges today, in trying to solve the riddle, which is how do I allow my GPU accelerated efforts to get to the appropriate data set. And if I can get them to the data set, can they get there with the performance required to have it be meaningful to the application I want to use? On top of that, what do I have to be considered about user identification and access control? Little side conversation, true story. At a large Fortune 10 customer not too long ago, and they told me the story about how they enabled inference within their infrastructure and had to turn it off within 2 hours because the rank and file employees were able to query and get return back of executive memos. They could read the headline and 2 lines of preview. Now, if they clicked on it, they couldn't get the entire memo because they had access control would step in. But the method for inference had no construct about user identification, right? It was acting like it was all public data. Yet it had crawled very sensitive data, right, in being able to provide the return. So the point I'm making here is we believe, and we can substantiate the conversation around enabling more GPU access to your data is going to require a complete re-architecture of your infrastructure. Now, you don't have to do it all at once. You can phase your way into it. But this is going to be very, very similar to what we saw in terms of how data centers had to get refactored for the what became hybrid cloud, right? And so indexing and cataloging your data, embedding vectors for your data so that it can be understood by GPUs for inference, keeping the vectors in line with real-time data. So as data is created, edited, or deleted, your vector database reflects that knowledge, or that state, I should say, of the data, the most current state of the data. User access control, as we spoke about. Performance within my storage system if I'm going to train or fine-tune a model. Performance if I'm going to have inference and I've got agents, right? What do we talk about in the news all the time, right? It's just a matter of a couple of years and every worker will have 1,000 agents. Bring that down by 2 orders of magnitude. Just say you had 10 agents. Is the current data platforms in your environment able to scale that access load by 10x right now? And the answer across the enterprise is no. So what we're focused on is bringing to bear, and our big innovation was around scaling an architecture called DACE, which stands for Disaggregated and Shared Everything, which can scale in multiple dimensions, whether it's performance or capacity, to allow you to store some data, build your catalog, have your vectors embedded, do all this without moving data around, but also be able to reach out to data that's not on the system and index it and make it available for your GPUs, but also just scale non-disruptively when you need to as your workload with agents go from 10x to 100x to 1000x. So it's a daunting challenge. It's a lot of details and nuance to make sure that everything is secured, right? You don't want data leakage. And we didn't even talk about agent-to-agent interaction and having to record all that and analyze it. But yeah, there's a lot of really interesting data-centric work going on just to bring the full vision of what GPUs can do to market.
You sort of answered my second question.
Oops.
I wanted you to take a look at what's look ahead for 2027, right? You sort of mentioned that, hey, multiple agents, not multiple, like dozens of agents per employee that are going to change your token consumption. How do you measure ROI? How do you figure out the whole infrastructure layer, model layer?
Yeah. Sorry that I'm still talking. So from where we sit, and look, there's lots of strategies, right? You were sharing a moment ago, right? You analyze the queries of the users so that you can look for efficiency in their token usage, right? That's one aspect. That's not a part that we're working on. We're working more on the back end, on the infrastructure, that the infrastructure is more efficient on your token utilization. And then the big area of investment in that space has been around vector databases. I'm sure many in the audience are familiar with. There's a lot of open source in-memory vector databases today. The challenge with the current in-memory vector databases is that they scale to about, if you're looking at a 768 dimension vector, they scale to about 1 million vectors per instance. And depending on, if you're applying that same 768 dimension to a petabyte of data, you're going to need about 3/4 of a petabyte of vectors to store, right? So it starts to become this financial equation where you're trying to save on tokens, but you're deploying a database technology or vector database technology today that is woefully underprepared to scale to where it needs to be, tomorrow.
You can save on token, but doesn't mean you can have the skill for the data layer.
Yeah, and just to level set, maybe I jumped into this too deep, which is the whole purpose of building out a cache, a vector cache, means that when someone first asks a GPU question, it gets vectorized and stored. And then every subsequent request that comes in, if it has a similarity match at a score of 95% or higher, which looks like a strong match, you just return the vector and the results back to the GPU. No token spent on the input or the output, right? So I paid on the first time, and every subsequent use, as long as it's a strong match, is free. So this is how that the CSPs and the enterprises that are investing in inference right now are looking to scale the GPUs 10 to 20x from what they currently would be able to accomplish without a vector database. And then the complexity within the enterprise of having a vector cache goes back to kind of what I referred to earlier about user identification and access control, right?
Yeah.
I want to make sure that what you get returned as a result versus what I get returned as a result, even when we ask the same question, is tailored to what your permissions are versus mine.
Right. It totally makes sense, especially for regulated businesses, for energy, for
Very.
government, right? So everything, yeah,
Oh, yeah.
100%. Back to Wilson. So we talk about solution architecture perspective, right? So what are not your customer, but what do you think people are getting wrong about how they provision and consume compute or anything that the workflow that entails?
Yeah, I
Where's
think
money get wasted, basically, from your point of view?
yeah, I think quite a few different aspects. One is, as you correctly mentioned, for database. I think for some other things as well, people ask similar questions, not only from internal users, but if we are offering agent to the general public, they ask similar questions. So that's how we come up with the idea of semantic caching. So whatever people are asking similar questions, you don't have to go each and every time go to the large language model itself. So that's one area. The other one is also from the security perspective. There are some, of course, a lot of legitimate users. There are also some attackers or people trying to abuse. And even, for instance, they just repeat the last question for 10,000 times. So these kind of prompt, if you don't have any measurement, the agent or even the general large language model can just follow the instruction and do whatever, basically meaningless. Yeah. So these can be put together from our solution architect perspective. We will suggest or recommend our customers to deploy one additional layer of AI gateway, so that we can just at least have some meaningful monitoring and just to make sure people are doing the right thing with these tokens. The other thing is maybe I think the keep improving the efficiency perspective. From our internal use perspective, we typically will leverage a few different large language models and let them debate sometimes to see which one has not necessarily each and every time one large language will always win, but we will have different roles. Some of them are representing a developer, doer, and the other one may be QA, just to challenge the other one's decision. So through that kind of internal competition, we managed to get the best use cases. Maybe in the first a few days or a few weeks, we are spending more tokens, but in the long run, we end up saving the efficiency, basically.
That's great. So we're gonna open to both of you next a few questions. We don't have that much time, but I'd love to talk about, let's keep follow the money, right? From the chip fab to cloud API, where do you think the margin actually lives in the token economy, right? Do you think the token lives with the model layer, the application layer, the cloud layer? I mean, we're having a breakdown to open source, open weights versus closed source models. What's your thoughts on who can capture the margins?
Okay, so in my opinion, of course, I think it's all kind of a supply and demand game, right? So whenever there is a scarce supply, of course, the margin goes higher. So last a few years, the GPU, apparently that's very difficult to get GPU. But right now, I think moving forward, the GPU is still scarce resource, of course. But in my opinion, the application, how to make good use of the workflow and how to make a better agent to help the enterprise make real use cases, that's where the value is. Where the value is becomes, it translates to where the profit lives with. So that's my opinion. For instance, in Tencent perspective, we have the game studios. So how to generate, use the best use of the AI tools to generate the characters in the game design. Or in our video streaming perspective, how to get a better enhanced video and generate the subtitles, everything, generate the excite moment in the sports games or whatever. So these things, if we make it more attractive, more value to our best experience, this is really where we can get the best profit from it. I mean, tokens becomes relatively commoditized.
Right. All right.
I could listen to Wilson all day. For where I focus my team within our business, and I should put an asterisk here because it's not representative of everything across VAST. So I focus primarily on semiconductor manufacturers, neoclouds, model builders, and SaaS companies. So
all the most popular
right.
ones.
So you make it, you host it, or you consume it. That's my customer base by and large. And so my focus, again, kind of reiterating, is more on the infrastructure piece. And so the from a cloud service provider perspective, but this would also apply to an enterprise. The ability to minimize token consumption within the infrastructure, right? Wilson shared higher level constructs. That's what I love, just the fit of this conversation. But within the infrastructure, within the vector cache, is the way to save tokens, right? To preserve the GPU resources. I'm reiterating something that I said before, but I wanted to take it a step further because I left off talking about the current in-memory vector databases can store about a million vectors. Our vector store stores 1 trillion per index. And so we're talking 6 orders of magnitude more vectors available to you. That results in faster returns on your searches. And the more that you can store in that vector database and not have to evict has this exponential effect on reducing token consumption, right? And so it's smarter, more integrated and intelligent infrastructure. You can piecemeal your infrastructure. I have these conversations daily with prospects. What we're trying to do is to bring something together that ultimately achieves the outcome. And in this case, when we're talking token economics, I'll go see where we're at with publishing some research results around tokens. I think this is a really good conversation to kind of continue on, in terms of some online perspective from us. But we've got a lot of data here that I think we should get out and share. But yeah, the smarter you can make the infrastructure, the more optimized it's going to be for these resources. And look, in the realm of your data center, your storage spend versus your GPU and infrastructure spends sub 5%. Like, we're still talking nothing, but it allows the more expensive portions of the build out to be accelerated and more valuable, going back to ROI.
That's great. We had one last question beforehand. So we talk about how, let's assume inference costs will drop, right? Which is no one knows, right? I would argue if closed source model keep taking a leadership position, a very obvious leadership position, then potentially they have the pricing power, right, to increase the prices versus open source models taking a leadership role, which people, can have a cheaper access to different LLM models. But assume inference costs gonna drop, right? What do you think about those cheap inference will create kind of new category of AI businesses? Just looking forward, just assume inference costs will continuously drop. Wilson, you wanna?
Sure. I mean, this may not be representing the majority of the, this is my personal opinion. So I would say, historically, a lot of people, enterprises are trying to build small language models by themselves or even in the private cloud. So with the higher training cost and relatively lower inference cost, I would foresee this part of the enterprises choosing to build their own private and small language model will relatively drop, because I think there are so many good models on the market to leverage, and they can, the large language models are upgrading so soon, so quickly. So that's, I think more of the customers will choose, the enterprises will choose to build infrastructure. Even we can deploy some of the inference infrastructure into the edge instead of every single time go back to the large language model. So with that kind of technology in place, I would see people would move towards having more inference infrastructure I mean, build the AI agent with a good, well-trained system prompt rather than building their own small language model. Yeah.
Yeah, I agree. I agree with your view on companies that are seeking to build their own small model. I think eventually all organizations are served best by focusing on what your market is. And so if you're not in the build AI models, say you're in a semiconductor manufacturer, right? You're probably better focusing on the semiconductor manufacturer and leveraging a model. In terms of open source versus the commercial models, I hear strong preference in both directions, depending on which customer I may or may not be speaking to. I don't know that I reflect either opinion. It's, I think at the end of the day, innovation wins out, and part of that innovation is the economics for that. So hypothetically, if you could get 85% accuracy from, say, an open model at 85% off of the cost of a commercial model, that's going to move some folks who just need general AI accuracy versus maybe someone who needs precision. And maybe that's going to be, maybe that ultimately might be the end of where we get, which is if you need a very sophisticated, precise model, it's going to come at a premium. So again, I don't have an opinion. Sorry, I don't have an opinion here. I'm just, I'm neutral. I'm Switzerland.
I just guess, you know, you pay the ROI again for the dollar per token, watts per token, right? You get what your investment for. So I don't think we have time for the next question, but before I end, any audience question? With 1-2 minutes left, that's then. If not, then thank you so much.
Right there, right at the end.
It's one.
Question.
I'm blind.
So what's the future of the token economy? Or what's missing today that we can expect it?
Oh, what's the future of token economy? Okay. So what I think, obviously, so we're an index provider, so I cannot give any forward guidance. So that's, you know, but just talk about the market structure itself, right? So if the majority of, so tech company, you traditionally don't have a raw cost of material to hedge, right? Your cost is a human being. In the future, let's say if you're a wrapper layer, application layer, majority of your cost goes to token. To Wilson's point, you would consume closed source models, right? You're paying, let's say 20% of your cost goes to token consumption, and that potentially need to hedge, right? So for you, it becomes electricity, your manufacturing, intelligence, and application, and then your cost is, instead of oil and gas and electricity, it's tokens. So other company will hedge your raw material commodity, which is oil and gas, and you should potentially hedge your token layer of cost fluctuation. So that's one of the things I think can potentially happen. Anything to add? All right, cool. Then happy Friday, and I'm sure they have next panel lined up for everyone here.